Finding out what happened in history is, of course, an important aspect of historical research. If we don't know the facts, if we don't know, for instance, that women in the Netherlands got the right to vote in 1919, then there's definitely something lacking in our historical knowledge. But historians, like other scientists, are not satisfied with just knowing a lot of facts. Historical books are not catalogues of facts. They don't just list one fact after another. They also try to explain those facts, make sense of them, allow us to understand why history happened as it did. Things could have happened differently. Women in the Netherlands could have gotten the right to vote in 1500 or in 2016. But if you understand the political history of our country and of Europe in general, you understand that in 1500 society wasn't ready for democracy, let alone for women's suffrage. And you also understand that by the end of the 20th century, no country in Western Europe could have failed to give the vote to women, although Switzerland and Liechtenstein made something of an effort. A historian interested in women's suffrage in Western Europe will be able to make this understanding explicit. She can explain why it happened in the early years of the 20th century and why some countries were later than others. But how exactly does that work? How do you explain historical events? What does the historian have to add to the bare facts in order to generate not just knowledge of the events, but understanding? In this lecture and several others in this module, we'll learn about different answers to those questions. In this particular lecture, we'll look at the ideas about historical explanations that were developed by Karl Hempel, who was one of the logical positivists. The logical positivists had a firm belief that deep down all the sciences work in the same way. Physics, psychology, history, they may look very different on the surface, but the same scientific method is at work in all of them. Hempel thought that this was true about explanation as well. All the sciences use the same kind of explanation. And if you know how explanation works in one science, you know how it works in every other science as well. With that thought in mind, Hempel looked at explanations in physics and constructed a model that became known as the deductive nomological model. Deductive nomological. What does that mean? Well, deductive is a word we already know. Hempel thinks that explanations are deductive arguments. Nomological comes from the Greek word nomos, which means law. Hempel believes that explanations use laws. What is a law? It's a link between causes and effects that always holds. For instance, it's a law that unsupported heavy objects on Earth fall down. And it's a law that if you cut off a person's head, they die. According to the deductive nomological model then, an explanation is a deductive argument that uses at least one law. So for instance, Hempel would consider this a good explanation in physics. All unsupported heavy objects on Earth fall down. When I let go of this apple, it became an unsupported heavy object on Earth, so this apple fell down after I let go of it. We can see that it's a deductive argument, and that the first premise is a physical law. So according to Hempel's model, this is a good explanation of why the apple moved downwards after I let go of it. Now, as I said, Hempel believes that history works just like physics. He writes, "Historical explanation 2 aims at showing that the event in question was not a matter of chance, but was to be expected in view of certain antecedent or simultaneous conditions. The expectation referred to is not prophecy or divination, but rational scientific anticipation which rests on the assumption of general laws." Hempel's reasoning here actually seems quite plausible. Historical events don't just happen by chance. Women's suffrage just couldn't have happened 100 years earlier or 100 years later. But Hempel says if it's not chance, then surely they must be governed by laws. What else could there be? So what would a historical explanation look like according to Hempel? Here's a potential example. Whenever there is a strong movement pushing for change in society and also a disruptive political event, then that change in society will happen during or soon after that event. In the first decades of the 20th century, there was a strong movement pushing for women's suffrage. The First World War in 1914 to 1918 was a disruptive political event. So, women's suffrage happened during or soon after the First World War. That's a beautiful deductive nomological explanation. The first premise is a general law, and the conclusion follows deductively from the premises. So, is Hempel right? Is that what an historical explanation looks like? Well, there are some grounds for worrying. Perhaps most importantly, there is the big question whether the law here is actually true. Is it really the case that whenever there is a strong movement pushing for change in society and also a disruptive political event, then that change in society will happen during or soon after the event? Well, it's not too hard to think of counterexamples. For instance, there was a women's suffrage movement in France as well, and the First World War disrupted France far more than it did the Netherlands. And yet, France granted women the right to vote only in 1944. Or what about the hippie movement, which flourished in the United States during the very disruptive Vietnam War and the assassination of John F. Kennedy, but which didn't bring about the kinds of societal change that it was pushing for? This is not a problem with this specific example. Historians just don't have the kinds of exceptionalist laws that physicists find in their laboratories. In fact, they don't seem to have any laws at all. You can read lots of history books without finding any historian who claims to have found a general law that holds everywhere in history. Whatever historians do in order to understand history, and it's an important question what that is that they do, it certainly does not seem to involve Hempel's deductive nomological model. Indeed, when we look at the women's suffrage example and the falling apple example, we can see a very important difference between historians and natural scientists. A difference which may explain why natural scientists love laws and historians don't seem to care about them. For a natural scientist, individual events are only interesting as representatives of something more general. A physicist looking at a falling apple is not interested in that particular apple. She's only studying it to learn something about falling objects in general. The natural scientist studies the individual thing in order to learn something about the general type. But that's not true for many historians. A historian will study the link between World War I and the women's suffrage movement not because she wants to know about a general law that links disruptive events with social change. She studies it because she is interested in precisely this particular thing, in the relation between World War I and women's suffrage. She wants to know about and understand the details of that particular episode of history. She studies the individual event in order to learn about the individual event. This is a very important distinction. It is not entirely clear-cut. Sometimes historians are interested in larger structures or in bigger comparisons. And certainly some other scholars in the humanities work more like natural scientists. A linguist, for instance, is rarely interested in a particular sentence, but is studying individual sentences in order to learn something general about the language. But for the most part, the humanities are more focused on understanding the individual, and the natural sciences are more focused on finding out general laws. That is a distinction that we will meet again in future lectures.